Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 23, 2025, so exactly a week ago. This paper introduces a model that can take a single image and generate a dynamic, explorable world, achieving an instruction following score of 0.657, which is a massive leap over previous methods. The paper is titled Yume, an interactive world generation model, and it effectively lets you walk around inside a static image using just your keyboard. It presents a full framework to create these high-fidelity videos, overcoming common problems like visual artifacts and poor camera control. Alright, and on X, the reaction has been really positive. Researchers and enthusiasts are sharing the project page, the code, everything. But the main thing people are buzzing about is the potential for gaming. One comment called the work insanely cool and suggested this is how we'll eventually get games like GTA 9. So the community is definitely seeing this as a major step towards truly interactive, AI-generated worlds, which is really exciting to see. Now let's dive into how the model actually works. Also, the authors shared their implementation on GitHub. If you head over there, you'll find the full source code, along with scripts to run inference yourself. They've also included instructions for training the model from scratch, and even point you to the dataset they used for the project. Okay, so this first figure really visualizes the core idea. On the left, you see a few input images, like a snowy street or a busy city. The Yume model takes one of these, and then, using your WASD keys, it generates a video where you move through that scene. To make this work, it uses camera motion quantization. This basically translates complex camera movements into these simple keyboard commands. The model then generates the video autoregressively, meaning each new frame is built upon the last one, plus your input. Building on that, the table of contents gives us a great roadmap of how they achieve this. The core of their method is broken down into a few key parts. First is the model architecture, which uses what they call Masked Video Diffusion Transformers. These help focus the model's attention on the important parts of the scene to boost quality. Then, there's the sampler design, which uses stochastic differential equations. These are math tools that add a bit of randomness to make the video sharper and more controllable. Finally, they tackle acceleration using adversarial distillation, a clever way to train a smaller, much faster model to mimic the big one. Okay, and this figure gives a fantastic visual breakdown of those components. On the top left, we see the camera motion quantization. It takes a real video's camera path and simplifies it into discrete actions, like W for forward. These actions are then fed as text into the model architecture, which uses Masked Video Diffusion Transformers. A diffusion transformer is a type of network that excels at generating video by learning to remove noise. The masking helps it focus. The bottom panels then show how it handles long videos, using compressed past frames as memory to generate the next segment, ensuring consistency. Moving to the results. This table really highlights how well that all comes together. It compares Yume against other top models like WAN 2.1 and Matrix Game across several quality metrics. The most important one here is instruction following, which measures if the video actually moves in the direction you command. You can see Yume scores a 0.657, which just blows the others out of the water. It also leads in subject consistency, background consistency, and motion smoothness, proving it's not just more controllable, but also produces higher quality, more stable video. So how do they make it fast enough to be interactive? This table validates their distillation method, a technique for creating a smaller, faster version of the main model. You can see the time drops dramatically, from over 580 seconds to just 158. The only real trade-off is a slight dip in instruction following, while the visual quality metrics like consistency and aesthetics remain almost identical. This is a huge win for practical use. And here we get to see what that looks like in action. On the left, you see several real-world examples: a forest path, a beach, a city street. In each case, the model starts with just one image and generates a smooth, continuous video sequence, as if you're walking through it. This really proves it can accurately follow those keyboard commands. But what's even more impressive is on the right, the edited scenes. The model can change the time of day, make a sunny scene snowy, or even shift the art style from Japanese anime to Pixar. In conclusion, Yume presents a powerful framework for generating interactive, explorable worlds from just one image. It really stands out for its keyboard controllability and visual quality, achieved through a smart combination of model architecture and sampling methods. It's a solid foundation for even more immersive future experiences. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.